Hello friends, welcome back to another awesome day. Day 56 of the 100 days of hell with Python algo trading. Recently, I have been receiving so many DMs on LinkedIn and Instagram that how we can use these mathematical formulas like PDF, CDF and the distributions like normal distribution, standard normal distribution in the real life stock trading. So I thought let's make an educational video and give you an insight into this. So today we'll learn how you can really use these concepts in real life algo trading. So without a further ado, let's get started. So before that, let me show you the action plan. So the first step will be fetching live data. So here what we'll do, we'll fetch the data of Apple and Tesla and we'll try to compare the various parameters, right? Then after fetching data, we'll try to understand the type of data, right? So let's say get to know the data. And then you will try to find the probabilities of various percentage, right? We can say. So what we'll do, we'll frame some questions and based on that, we'll try to find the CDF, right? Okay, let's start then. So before moving further, I would like to explain you the standard normal distribution again. It's very easy and very quick. So let's say this is your curve, like your standard normal curve. So in theory, it is coming from negative infinity to positive infinity, and this blue line is not touching the white line. But for the practical purposes, we assume that it is touching, right? And then when we talk about the standard normal curve, we have to take the mean as 0 and standard deviation as 1, right? And we also know that mean is here, right? Which is 0. Actually, yeah, it's okay. Don't focus on my drawing. Just try to understand the concept, right? Then you can say it is going from 0 to -1, +1, again -2 and +2, right? Again -3 to +3, and we know that the area under the whole curve, so you can write here area under the curve is 1, right? So we can say that the half area, half means where mean equals to 0, so we can say the half area will be 50%, correct? And the probability will be 0.5. These are some parameters we already know about the standard normal distribution. So it makes our life very easier when we standardize any data. And in Python also, so many formulas, by default, they assume that the data is already standardized. So it becomes important to understand and then standardize your data. Okay, let me tell you few pros and cons of standardizing your data. And what are those? The first is simplicity, right? Your life becomes so easier when you standardize any data. Second is universality, means the standard normal table or Z table or the functions of the standard normal distributions are widely available and you can use them straight away, right? Third, there are so many theories or methods which already assumes that your data is already standardized, right? So because of that, mostly we standardize our data, right? And here also we know that these 0, 1, 2, 3 are Z values, right? Z values. And also to calculate the Z, what you have to do, you have to write X minus mean over standard deviation, right? And this Z table is available widely. Okay, now let me take an example here only, then we'll proceed with the Python. Let's say you fetch the price of 3 years of Apple data, 3 years. What you do, you try to find out the percentage change. So in that column, you have the value and you also have the mean. Let's say Apple close, right? So for this, you have the mean, which is equals to, let's say, 0.03, just assumption. And standard deviation is, let's say it is 0.02. And you take a single value of a day, let's say it is 0.035. Right? Just for this example, now we have two options. One is to apply the mathematical formula directly into the Python. We can convert the mathematical formula. Other option is to use already existing libraries and we can take help of that. From both, the answers will be exactly equal. And we can find the probabilities with the normal data or also we can first standardize the data and then find the probabilities. The values will be exactly same. So let me quickly show you. So let's say the first option is to apply the formula of PDF and CDF, which is, we know, PDF for normal distribution. For normal, PDF is equals to, this is PDF, you can say F. Here you can take both, like X or mu and sigma, which is equals to 1 over sigma 2 pi, then e to the power x minus u square over 2 sigma square, right? And similarly, the CDF of this will be, we know that CDF is the area under the curve, right? And area we can find with the help of integration, right? So you can simply write like 1 over 2 pi, which will be equals to minus infinity to x e to the power x minus u square. So we can do with this also, right? No problem. And when we check about the standard normal distribution, standard, we have seen that for standard, the values are mean equals to 0 and sigma equals to 1, right? And we have to find the value of z. So you can convert the formula quickly. So what you will do, you will write the PDF will be fz 1 over 2 pi, because this will become 1, then e to the power x square over 2. Simple. And CDF is, you know, the area under the curve, or you have to go minus infinity to z, and then it will be like e to the power x square over 2. The second option we have, we can use the already existing libraries like SciPy. In that we can use the norm function and we can straight away find all these values. So we can find the PDF and CDF of the normal data, or we can also first standardize the data and then find the PDF and CDF, right? That's very easy. And here, this session will be of 2 parts. In this, we will try to understand the data, and then in the next session, we'll try to find out the questions based on the analysis, right? So our plan of action here is that first we will pull the data of last 3 years of Apple and Tesla. Then we'll try to compare the data, that how it is distributed. Then we'll find the percentage change so that we can find the percentage return of the stocks on any given day. So now what is our plan of action? First, we will fetch the data. Let me write it. We have discussed, by the way, but let me again write it. First, we will fetch the data of 3 years, right? Apple and Tesla. And then we will try to analyze the data. So analyze, we'll plot some histograms. Then we'll find the basic parameters like the mean, standard deviation, z-score. And then we'll find the CDF, both with the normal distribution and with the standard normal distribution. So that is our plan of action. If you can see on the screen, the required libraries are pandas, numpy. Then we have to import the norm from the SciPy, then Seaborn to plot some charts, and the Yahoo Finance. So let's start. So first of all, we will fetch the data. So for that, what I'll do, I'll write a yf dot. Let me make it a little bit bigger. So what I'll do, I'll write yf dot download, and here we can give the ticker, that is Apple. And let's see, it says, okay, we have to make it tickers. Okay, we have. So now we have to define the range. So let's say today is 19th of July. So what I'll do, I'll fetch the data from July 21 to July 24. So start will be the July 21, which is 21, July, and 19th of July, and it will be 24 July, right? And when I run this, you will see that we have the last candle, which is 18th of July, and on which we have the close 224.17. Similarly, we'll try to fetch the data for Tesla. So TSLA, and let's run this, and we have the same data for the Tesla, and let's assign them a variable. So it will be Apple, and it will be Tesla, right? So let's run this. Okay. For now, we are interested in only one column, and that is the close price, right? So what I will do, I'll just go and print the close price for Apple, which is this one, and for Tesla, we have this, right? Now let's try to plot the chart of this close price and see how is the distribution. So what I will do, I'll first draw for Apple close. So for that, what I can do, I can use the function, I can use sn.histplot, and here I can pass the Apple close value. And when I run this, you will see this data distribution, right? And if I turn on the KDE, which is kernel density estimation, true, we can also get a curve, right? But here when we observe, we can see that it is not exactly normally distributed, right? Similarly, when we draw for Tesla, so let me do that. And let me comment out the Apple for now. And here also we can see that it is not normally distributed, right? So generally what we do, we find the close percentage. So here what I'll do, instead of doing this, I'll just remove for now. And first I will check the describe of this Apple. And then for Tesla also, let me print on another line. And this is for Tesla describe. So here, if you observe that we have the mean price of 166, the minimum is 125, the maximum is 234 for Apple. And similarly for Tesla, we have the mean 239, standard deviation is 59, minimum is 108 and maximum is 409. Okay, now let's go to trading view and check whether this data is correct or not. So I will open the trading view. If you can see on the screen, I have the Apple, and on Apple, when I check this, I have the last 755 bars, right? Means 3 years. And here when we check, and this is the mean, and this is the first standard deviation, right? If I click here and I mark this second, then it will also display the second standard deviation. You can see here, this one is the second. If you observe here, for the last 3 years, the lowest was here. If you can see here, it was close to 124 on 3rd of January 23. And if you open the Python again, so here you can observe that it is, the minimum is 125, the maximum was on this date, and which is, let me zoom it a little bit out, and the maximum is this on 15th of July, which is 237. So means it is correct. Similarly, when you open for Tesla, TSLA, you can see here for the last 3 years, let's wait and check. In Python, when we check, the minimum is 108 and maximum is 409, right? Means it is highly volatile. And when you check on trading view, 108 and 409. So it is taking some time. Okay, now we have. So the minimum for the last 3 years was 108, which is close to here, and maximum is 4, this one, right, around 413, which is same, right, in Python also. Okay, now let's analyze the data more. So I'll open the Python. It was a basic introduction that how you can relate your charts with your data. Now we have done this. Okay, now let's draw the histogram of both the Apple and Tesla. So first I'll go here and type sn.histplot, and I'll paste the value of Apple here. So you can see here it is the histogram of the Apple prices, and similarly for Tesla, this. And we can see that it is not exactly the normal distribution when we turn on the KDE, which is kernel density estimation, right? So here what we are trying to do, we are trying to find the daily percentage change. So for that, what I'll do, I'll go here and add another cell here, and here I can write Apple, then close, and then percentage change. And this is the percentage change on 20th of July 21, it was 2%. on 21st of July 2021, it was 0.5% on 21. Similarly, on the 18th of July 24, it was negative 2%. So I'll assign it PCT Apple, and I'll copy and paste it here for the Tesla. This is for Tesla. So now when I draw the histogram of this, it will be hist plot and PCT Apple. This is the normal distribution. And when I turn on the KDE, you can see here that we have the curve which is close to normal distribution. Similarly, I'll draw for Tesla. And this is also a normal distribution. Okay, now let's go and try to find the probabilities, that is CDF. So what I will do, first of all, I'll write PCT Apple, which is this. And for this, let's try to find some values which are the mean, standard deviation, right? So I'll just apply this describe function. And for Tesla also, I'll apply the describe function here. So it will be this. And here you can observe that the mean percentage change of Apple is 0.007 on daily basis, while for Tesla it is 0.008. Similarly, the standard deviation is 0.01, while for Tesla it is 0.03. Means Tesla is more volatile. Yeah, definitely it will give you more returns, but it is more volatile on the both sides, upper and lower. And you can see here that minimum for Apple was 5% on a single day and maximum is 8%, while for Tesla the minimum is 12% on a single day and maximum is 15%. Means Tesla is high risk and high reward stock. So with just a describe function, you can find a lot of information about the data. Now let's proceed and find the CDF. So we have discussed that first we will find the CDF of the normal data, and if we want, we can also standardize the data first and then we can find the CDF. So let's do that one by one. So let me write here, and we know that to calculate the CDF, we just need the mean and standard deviation. So I can write the formula here, norm.cdf, and I can pass the value, which is the percentage change in Apple, which is this, and then the location, which is the mean. And let's go to the Apple and find the mean 0.0007, and I'll pass here. And then I can pass the scale, which is the standard deviation. So scale is equals to this one. Okay, now let's run and check this cell. We have the CDF of the normal distribution, which is like you can see here an array, right? And if we want, we can do the same with the standard normal distribution. And for that, we have to find the z-score. And we know that the formula for z is x minus mean over standard deviation. So let me write here z equals to x, and here x is the percentage change. So I'll write here PCT minus the mean of this. So I can write like this, and then the standard deviation of this. So yeah, this is z, and now I can simply pass in this norm.cdf and only z, and by default it will assume that the data is standardized, means mean is 0 and standard deviation is 1. So when I run this, and now when you can see here the CDF is 1.0, and when we check with this, it is 9.27, which is not equal, and ideally it should be equal. So what is the mistake here we have made? Let me check. And here if you see, we have divided with the mean again, and we know that the formula is STD, standard deviation. So when I run this again, now you will see that we have exactly same, right? 9.27 and 9.27, and the last one is 1.08, and here also 1.08, means exactly same. So which means if you want, you can first standardize your data and then you can find the CDF and it will be exactly same. We have done for Apple. Similarly, let's do for Tesla. So I'll write here CDF Apple, and I'll just copy and paste it here, and I'll write for Tesla. Right, so normal.cdf and Tesla. And for the mean and standard deviation, I have to assign these values here. So this will be the mean of Tesla, and this is the standard deviation, right? And I can run this here. It says I forgot something here. Okay, I have put 2 decimals. I'll remove this and run. Okay, similarly, I'll change it to Z apple, and here also I can pass Z apple. I copy, or let's do it again whole. So for Z Tesla, it will be PCT Tesla minus PCT Tesla mean and over PCT Tesla.std. And when I run this, it works fine. And let's find the CDF of this also. So I'll assign the value CDF apple, and this is CDF Tesla, and for that I have to pass norm.cdf and Z Tesla, and here it will be Z apple. Okay, let's run all these cell again, this also and this also. Actually, I have like made both these same. I'll just assign S here so that we can differentiate between the normal distribution and standard distribution. So I'll run again both these, and now let's compare the value again one last time. This is the CDF for apple with the normal distribution. So CDF apple, which is this one, you can see here 9.27, and let me make it a series. So what I will do, pd dot series, and you can see here we have the series. Similarly, let's check for the SDF, and you can see we have exactly the same values, right? You can see here the initial 5 values are 0.9 to 0.74, right? And when we check for Tesla of both, so it will be Tesla and this will be for SCDF, and it is also exactly same. That means we can find the probabilities from any normal distribution or standard normal distribution. It's up to us completely. And now, as per the property of standard normal distribution, we know that the area under the curve is 1. So we can subtract those values from this and we can find as per our requirement. Now, let me tell you few more observations, which are, let's draw the histogram of these values. So we'll focus mainly on the standard distribution. So what I will do, let's say we have the series for Apple and we have the series for Tesla. So I will just assign a value, let's say SD Apple, and similarly SD Tesla. Now what we'll do, we'll try to draw the Z values of both the Apple and Tesla, and let me give you a few insights at how we can analyze the data. So let me draw that. First, I'll draw the histogram of Z of Apple, and which is this one, and let me turn on the KDE, which is kernel density estimation. You can see here it is exactly like normal distribution, standard normal distribution. And when I draw for the Tesla, which is this, and here also you can see that the mean is 0 and standard deviation is 1. It is always 1, and the area under the curve is 1. So with those properties we can find a lot of things easily. Now let's apply the describe function on Z Apple. Apply that. If you remember, we applied the describe on both the Apple and Tesla, and here you can see that the standard deviation was 0.017 for the Apple and 0.03 for the Tesla. Means it is highly volatile. Let me show you on the screen that how it works, so you'll get more insight. 0.08% and standard deviation is 3.6%. You can see also on the screen the mean value and the standard deviation value, right, of both the Apple and Tesla. Okay, so when we draw this plot for the Apple, it will be like this. This is the mean, which is 0.07. 0.07. Then we have the first standard deviation. Then we have second standard deviation. And last we have the standard deviation, the third standard deviation, right? And after that, these values are unknown. We do not know that, right? This is coming from infinity to positive infinity. Now, similarly for Tesla, it will be 0.08. This will be the first standard deviation. This will be second standard deviation. And this will be the third standard deviation. Now when we check about this 3.6, means we have to subtract from this 0.08 and we have to add in this 0.08, right? And when we do it 3 times, so 3.6 multiplied by 3 is 10.8. Means in the last 3 years, 10.08 plus 0.08, which is 88, means negative 1088, and when we subtract this, it will be negative 11 to positive 11, which is a very high volatility. Means you have high risk and high reward. Similarly, when we talk about this, it is only 1.7. Means volatility is less in the Apple. And here also the mean 0.07 and it is 0.08. Means it is giving you more returns, but it is also very high volatile. Means it is also very risky. So whenever you are creating your portfolio or you are like looking for any good opportunities, you always have to consider all these things, right? The risk and reward ratio. That is very, very important, right? So I think this was it for this video. We will cover so many amazing things in the upcoming videos with the options. And if you have any doubt, please let me know in the comments. And I'll see you in the next video. Until then, bye bye, take care, have a nice day.